Hey everyone, this is Math 105, Lesson 14, Unit Conversions using Dimensional Analysis. So if we're going to convert units from one to another, we need a conversion factor. The conversion factor is something you multiply by to change from one unit of measure to another. So on the first page here you see a bunch of conversion factor. These are equivalent measures, and it's broken down to length, the volume, and weight. So an example of a conversion factor is 1 mile equals 1.61 kilometers. So suppose this distance represents 1 mile. We can represent the exact same distance with a different unit, 1.61 kilometers. And it's important to realize that these two things represent the exact same distance. Because when we create fractions out of these, the fractions have to have a value of 1, meaning the numerator and the denominator have to be equal to each other. So I'm going to go through the procedure for unit conversion with the first example. Now the first examples we're going to look at, only one conversion factor is needed to do the unit conversion. So for example 1, we're going to convert 12 feet into meters. All right, step 1, write the given quantity with units over 1. The only exception to this is if we have a rate. A rate has units in the numerator and the denominator, but most of these will only have units in the numerator for the first fraction. So starting quantity is 12 feet, so we're going to write 12 feet with units. You have to include units. It's part of the technique. Over 1. So there's our initial fraction. Now we're going to multiply by another fraction made up of a conversion factor. So go to the table now. We're going to create a conversion factor between feet and meters. So for length, it says 1 foot equals 0.305 meter. Now there are two fractions we can create out of this. We could put the feet on top. Or we can put the meters on top. Both of these fractions have a value of 1 because 0.305 meters equals 1 foot. So the top and bottom are equal. Now we're going to orient this fraction so that we get rid of the feet and we keep the meters. So in order to do that, since we want to get rid of the feet have to be on opposite sides of the divisor line. That way they cancel out. Anything that matches on top or bottom cancels. It doesn't work just with numbers, it works with units too. So the feet are gone, and we're left with meters, and that's what we're looking for. Now to multiply fractions, we're going to multiply straight across on the top, straight across on the bottom. So we do 12 times 0.305. So that gets us on top 3.66, on the bottom just 1 times 1. So that is 3.66 meters. So now we know that 12 feet equals 3.66 meters. Your turn number 1, convert 9 inches to centimeters. And just a reminder to pause the video while you work on your turn. All right, now we need a conversion factor between inches and centimeters. So there's two choices. And from the table, we have 1 inch equals 2.54 centimeters. So there's our two choices for the conversion factors. All right, now we're starting with 9 inches. So our step 1, write that as a fraction over 1. And now we're going to choose The conversion factor is that is inches on the opposite side. So that is 1 inch on the bottom, 2.54 centimeters on top. The inches cancel, and we're left with just centimeters. Now multiply straight across. 9 times 2.54 gives us 22.86. And just 1 on the bottom, so that is 22.86 centimeters. So 9 inches equals 22.86 centimeters. Example 2, 0.3 gallon, 2 liters. All right, so in step 1, write the initial quantity as a fraction over 1. So we got 0.3 gallons over 1. Now we need a conversion factor between gallons and liters. So go to the table. 1 gallon equals 3.79 liters. So there's our 2 choices. We want to select the one with gallons on the bottom because we're starting with gallons on the top, and those are the units we want to get rid of. Right now we got gallons on top and the bottom, so those cancel. And we're left with, the only units remaining are liters, and those are the ones we're looking for. So we're going to do 0.3 times 3.79. That gives us 1.14. The only remaining units are liters. So 0.3 gallons equals 1.14 liters. Your turn, number 2. Convert 0.042 ounces to grams. All right, first fraction, 0.042 ounces over 1. Now we need a conversion factor between ounces and grams. So from the table, the units of weight, 1 ounce equals 28.35 grams. Ounces on top and bottom, so those are going to cancel out, leaving just grams. Now we'll multiply straight across. 0.042 times 28.35. 1.19, the only units left are grams, so that's the units of our answer. So 0.042 ounces equals 1.19 grams. Now the metric conversions we did last time, these can be done with dimensional analysis. Example 3, 2.59 decameters to centimeters. Now from our table, to go from decameters to centimeters, we're going down 3 places. All right, 1 to get to the base unit and 2 more to get to centimeters. So that means there are, in 1 decameter, 1,000 centimeters. So now we can cancel the units on top and bottom to match. Decameters are gone, leaving only centimeters, so we're going to multiply 2.59 times 1,000. That moves the decimal over 3 places. 2590. So 2.59 decameters equals 2,590 centimeters. Your turn, number 3. Convert 0.56 kilograms to decigrams. All right, kilo to deci. So it takes 3 steps to go from kilo to the base unit, and then 1 more step to get to deci. So that's 4 steps. So that means there are, in 1 kilogram, 10,000 decigrams. Kilograms cancel. So we're going to take 0.56 multiplied by 10,000. That gets us, move the decimal over 4 places, 5,600 decigrams in 0.56 kilograms. All right, so that's fine if we've got a single conversion factor between the units we're given and the units we want. But that's not always going to be the case. Sometimes we require more than 1 conversion factor. So with example 4, we are converting 500 ounces to kilograms. And for this course, make sure that you're only using conversion factors from the tables. We're starting with 500 ounces. Write that over 1. Now we need to trace a path from ounces to kilograms. So take a look at the tables. So we got, starting with ounces, we got kilograms over here. There's going to be some unit in the middle where we go ounces to something and something to kilograms. So if you look through the tables, 1 ounce equals 28.35 grams. So we can go from ounces to grams. We just have to determine if it's easy to go from grams to kilograms. Well, that's just a straight up metric conversion, so we know those conversion factors. So there's the path we need. So that means we're going to need to do 2 multiplications. We need 2 extra fractions. First fraction goes from ounces to grams, so we need that conversion factor. So like I said, 1 ounce, 28.35 grams. 1 ounce goes on the bottom, 28.35 grams on top. Now we need to go from grams to kilograms, and there are 1,000 grams in 1 kilogram. These are 3 steps from kilograms to grams. Now we need to go through and make sure all the units we don't want are canceled out. All right, we don't want ounces. Ounces are gone. We don't want grams. Grams are gone. The only units remain are kilograms, and that's what we're looking for. So we have it set up correctly. Make sure you only cancel things on top and the bottom. Never cancel things that are on the same side of the divisor line. Now we multiply straight across. So on top, we're doing 500 times 28.35. And on the bottom, we got 1 times 1 times 1,000. So 1,000 on the bottom. And we multiply that out and divide by 1,000. We get 14.175 kilograms. And in general, you can round to 2 digits. I'm just going to leave it for this one. Your turn, number 4. We're going to convert 0.04 quarts to milliliters. So from the table, we can do a conversion from quarts to liters, and then a metric conversion from liters to milliliters. So we're going to need two fractions. First, quarts to liters. So from the table, units of volume, 1 quart equals 0.946 liter. Now the next conversion is going to be from liters to milliliters. 3 steps on the metric scale. So it's 1,000 milliliters for 1 liter. Right, now let's cancel the units. Make sure we're set up correctly. Quarts on top and bottom, those cancel. Liters on top and bottom, those cancel. Only units to remain are milliliters, and that is what we're looking for. So that is set up correctly. Now multiplying straight across, looks like we just have ones on the bottom, so don't need to worry about those. We're going to do 0.04 times 0.946 times 1,000. We get 37.84 milliliters. So 0.04 quarts equals 37.84 milliliters. Well, that brings us to your turn. Number 5. So, other than the marathon, the longest Olympic running event is the 10,000 meter run. Convert this to miles. So we're starting with meters. We want to get to something that's going to get us to miles. We know there's a conversion in the table between kilometers and miles, so we can go from meters to kilometers and kilometers to miles. All right, first is the metric conversion. It's 3 steps on the scale, so that's 1,000 meters in 1 kilometer. Then we have 1.61 kilometers in 1 mile. Make sure you don't use M as an abbreviation for mile because M is reserved for meters. If you want to abbreviate mile, just go MI, period. Multiplying straight across, we get 10,000 on top. And the bottom, 1,000 times 1.61, that's 1610. Divide that out and we get 6.21 miles. How anybody's able to run 6.21 miles that fast, I don't know. You ever see those people? It's amazing. Don't even get me started about the marathoners. Now, some conversions can't even be done in 2 steps. Some are going to require 3. Example 5. 26 pints to deciliters. So we're going to need to get from pint to something to something to deciliter. Well, let's take a look at our tables. We've got a conversion between pints and quarts, and I know quarts leads to something, so let's try that. We'll go quart, and I know there's a conversion between quart and liters, and then liters takes us to deciliters, because that's a straight up metric conversion. All right, so there's our path. So first, what was that? 2 pints is a quart, so 2 pints here, 1 quart. And now we'll go quarts to liters, so that's off the original table. And 1 quart is 0.946 liters. And then we got 1 liter and deciliters. See, deci's 1 step below, so that is 10 deciliters in 1 liter. So multiplying straight across now, we've got 26 times 0.946 times 10. On top and on the bottom, 1 times 1 times 1 times 2. And we get 123.0 deciliters. I just want to confirm I canceled correctly. Pints, pints, quarts, quarts, liters, liters, leaving deciliters. So we're all good. Your turn, number 6. Convert 25,000 hectograms to tons. All right, we need to go from hectograms to something to tons. Well, sometimes it's helpful to work backwards. So look at ton. There's only one conversion factor in the whole thing, and that's the pounds. So I'm going to put pounds there. And now we need to go from hectograms to pounds. Well, if we go from hectograms to kilograms, there's definitely a conversion between kilograms and pounds, and this is just a metric conversion, so it looks like that path is going to work. So we'll need 3 fractions. Now we'll go from hectograms to kilograms. It goes deca, hecto to kilo. So it's only 1 step away, so that gives us 10 hectograms in 1 kilogram. So there's the first one. And now from kilograms to pounds, maybe they use the 2.2 in this one. Nope, we're doing the other one. 1 pound is 0.454 kilograms. So 0.454 kilograms is 1 pound. And now from pounds to tons, we got 2,000 pounds in 1 ton. All right, let's cancel these units. Hectograms, those are gone. Kilograms, those are gone. Pounds, those are gone, leaving just tons, and that is what we're looking for. So that is set up correctly. Now on top, we're doing 1 times 1 times 1 times 25,000. So we get 25,000 on top. And on the bottom, we're doing 10 times 0.454 times 2,000. So that gives us 25,000 over 9080. Divide that out and we get 2.75 tons. Your turn, number 7. We're going to convert 432,000 seconds into days. So our path is pretty clear on this one. Seconds to minutes to hours to days. Canceling units, you got seconds, those are gone. Minutes, those are gone. Hours, gone. Left with days. So multiplying straight across, we got 432,000 on top. And the bottom, we'll multiply 60 times 24. $86,400. Finally divide this out and we get 5 days. And sometimes a work week feels like every one of those 432,000 seconds. All right, last up we're going to do unit conversions involving rates. So rates are things with units on top and bottom. Now the first one we're going to look at, we're still only going to convert the top rate, or the top unit. We'll just leave the bottom one as it is. So example 6. We're going to convert 38 feet per second to meters per second. All right, so when you line these up, first fraction has to have units in top and bottom because it's feet per second. So you put the 38 feet on top, and the per bar part goes on the bottom, so 1 second on the bottom. Right now, we're only converting the top unit because our goal is meters per second. We get the same units on the bottom, so we don't need to do anything with those units on this one. We're just going to go from feet to meters. So that gives us 3.28 feet in 1 meter. Now I'm multiplying straight across. We got 38 on top, 3.28 on the bottom. Divide that out, 11.59 meters per second. Your turn, number 8. 100 kilometers per hour to miles per hour. So the units we want are miles per hour. That matches what we have in the bottom already. So we'll just leave that alone. We're just going to convert the kilometers. 1.61 kilometers per 1 mile. So that gives us 100 divided by 1.61. Divide that out and we get 62.11 MPH, miles per hour. Now with some rate problems, both the top and bottom units need to be converted. So with example 7, we're going to go from meters per second to feet per minute. So 34 meters per second, write that as 34 meters over 1 second. Sometimes the 1 is omitted, and just write second. Everybody knows it's just 1. Now we need to convert 2 things. We got meters per second to feet per minute, so we're going to go from meters to feet, and we're going to go seconds to minutes. Now we need to be real careful about the units. We have the way we position these fractions. So we have two conversions, so we'll need two fractions. Let's do the meters first. Meters to feet. And the conversion there is 0.305 meters in 1 foot. Now we need to convert seconds to minutes. Make sure you orient this fraction so that seconds are on top because we need that top and bottom seconds to cancel. So 60 seconds on top and 1 minute on the bottom. Let's make sure our units cancel appropriately. Meters cancel and seconds cancel. Now let's see what units we have. We got feet, the divisor line is per, bottom is minute, feet per minute. That's what we're looking for. So on top, 34 times 60. And on the bottom, we got 0.305. Multiply on the top, divide by the bottom, we get 6688. 0.5. 6,680.5 feet per minute. Your turn, number 9. Convert 5.7 pounds per gallon to kilograms per liter. So this is a measure of density of a liquid. All right, so we're going to convert pounds to kilograms. So we use that conversion, 1 pound equals 0.454 kilograms. And now we're going to do gallons to liters. So 1 gallon is 3.79 liters. Pounds cancel. And gallons cancel, leaving kilograms per liter. Now we'll find straight across on top. 5.7 times 0.454. We get 2.5878. On top, and on the bottom, 3.79. Divide that out, get 0.68 kilograms for every liter. Your turn, number 10. Convert 34.8 quarts per day to milliliters per minute. So this is a flow rate for a liquid. We're going to convert quarts to milliliters. So that's going to require a couple of different moves. We'll do quarts to liters and liters to milliliters. So 1 quart is 0.946 liters. Now we need to go to milliliters. So 1 liter is 3 steps on the metric scale, 1,000 milliliters. All right, we're going to need one more conversion factor as we go. Let's see. Oh, days to minutes, we're going to need two more. All right, days, 1 day. Oops. It's 24 hours. And 1 hour, 60 minutes. All right, so make sure we got this set up correctly. Quarts cancel. Liters cancel. Days cancel. And hours cancel. So what do we have left? Just milliliters on top per minute on the bottom. Milliliters per minute. So multiplying straight across, we got 34.8 times 0.946 times 1,000 times 1 times 1. So we got 32,920.8 on top. And on the bottom, 24 times 60, that's 1440. Divided out, we get 22.86 milliliters per minute. So as we'll see in the coming lessons, dimensional analysis is an incredibly powerful technique, single most powerful technique in all of applied mathematics.